Okay guys, now we're going to look at chapter 4, section 2, and this is where we take all the stuff that we talked about in section 1 and use it to actually start graphing polynomials. Now, you can graph a polynomial by making a t-table, guessing a lot of x's, plugging your x values in, yielding a number of y's, but what you're going to do is you're going to miss a bunch of nuances about graphs if you don't look for certain characteristics like maximum, minimum, intervals of increasing, intervals of decreasing, etc., x-intercepts. So the idea is that on page 311, you have a list for how to graph polynomial functions. And it's probably pretty important to make sure that you're at least familiar with the steps and the characteristics that you need to find to be able to effectively graph a polynomial function. So I would start with that list. Now, let's look at an example, and I'm going to walk you through all those checklists. So for example, let's say that we want to graph h of x equals negative 2x to the fourth plus 3x cubed. First thing we need to do is to use the leading terms test to determine the end behavior of the graph. So if we look at this polynomial, our leading term is negative 2x to the fourth. First of all, we have x to the fourth, and that is a parabolic curve. And since our leading coefficient is negative, you know that it's going to be some sort of upside down parabolic curve, at least at the endpoints. The next step is to try and figure out what goes in the middle, what goes in between. So step number 2 is to find the zeros of the function. And don't forget, when we're talking about finding the zeros, you're trying to find the places where the graph crosses the x-axis. Finding the zeros is another way of saying find the x-intercepts. So, the idea here is that we factor this. So if we have negative 2x to the fourth plus 3x cubed, we can pull out an x to the third, and we're left with negative 2x plus 3. And of course, you can use your zero property rule. So either x cubed equals 0, which means x equals 0, or negative 2x plus 3 equals 0. Negative 2x equals negative 3. X equals positive 3 halves. So your zeros, or where your graph is going to cross the x-axis, is at 0 and 3 halves. All right, step 3. What we need to do is notice that the zeros divide the x-axis into 3 parts. So if you were just to look at the x-axis, you have 0 and you have 3 halves somewhere. You have part number 1, you have part number 2, and you have part number 3. So we're dividing the x-axis into 3 parts. Now, to talk about the intervals that this creates, this first interval goes from negative infinity to 0. Your second interval goes from 0 to 3 halves. Your third interval goes from 3 halves to infinity. So what you need to do is choose an arbitrary value in each interval, and we're going to test the value that you choose to figure out whether the graph is increasing or decreasing. Let me make some more board space here. Okay, so we have our 3 intervals, and we're going to make a little bit of a table. So we have the interval, And the intervals we've identified were from negative infinity to 0, from 0 to 3/2, and then from 3/2 to positive infinity. Now, first thing, we just need an arbitrary test value. And as I said, you can pick any arbitrary number provided that it's in the interval. So here, I'm going to choose -1. This value, I'll choose +1. For this value, I will choose 2. Doesn't matter, they're arbitrary numbers. The next step is then to plug those numbers into the function and find the function value. So if you were to plug -1 into our function, gosh, at this point, I've forgotten what the function is. -2x to the 4th plus 3x cubed. So if you plug -1 into the function, your h of x is going to be equal to -5. Your 1 will be equal to 1. And your 2 will be equal to -8. Okay? If you choose different values for each one of these intervals, these values will be different as well. That's not the point of this exercise. What we want is the sign of the output. So the sign of h of x. This is clearly negative, this is clearly positive, this is clearly negative. And irregardless of which arbitrary values you choose, your result should still have the same sign, even if it's a different number. Okay, and then the last part of this step 3 is to find the location of the points on graph. So this first one, because it's negative, is going to be below the x-axis. This one is going to be above the x-axis because it's positive. And this one will be below the x-axis. So, with this in mind, we're learning about the behavior of the graph, but we've also generated 3 new points that we can actually plot on the graph. Don't forget, these are ordered pairs. You plug in -1, you get out -5. You plug in 1, you get out 1. You plug in 2, you get out -8. And the more points you can generate along with trying to figure out the behavior of this graph, the better off you're going to be. So I'm going to continue this in another video so I can upload it to YouTube successfully.